the Remainder Theorem and the Factor Theorem. Before we work through this video, you need to know how to divide polynomials. If necessary, you should refer to the following video which covers this topic. Thanks for watching this video and don't forget to like, subscribe to the channel and activate the notifications. It is very important to the continuity of this channel. Let's start by remembering how to evaluate a polynomial. When you evaluate an expression for a given value, you substitute that given value in the expression and find its numerical value. Let's try an example. Substitute -2 for each x in the polynomial. Following the order of operations, evaluate exponents first. Perform the multiplication next. Combine terms. Begin from the left and find the sum. When you evaluate a polynomial for a given value, you find its numerical value. In other words, the numerical value of the polynomial p of x for x equals -2 is 7. Now that we remember how to evaluate a polynomial, we can learn what the zeros of a polynomial are. Zeros of a polynomial. We say that a zero of a polynomial p of x is a number k such that p of k equals 0. Let's see how it works. Determine whether the given numbers are zeros or roots of p of x. We replace x with -1, and the numerical value of the polynomial for x equals -1 is 18. So -1 is not a zero of the polynomial. We now replace x with 1, and the numerical value of the polynomial for x equals 1 is 0. So 1 is a zero of the polynomial. Before working through the remainder theorem, let us start by remembering how to divide two polynomials. The process of polynomial division is the same as that of long division of numbers. We can write the result in the form dividend equals divisor times quotient plus remainder. But we know that dividing polynomials either by the long method or by the synthetic method is a cumbersome process, and in some instances we are only interested in the remainder. When we divide a polynomial p of x by a linear factor x minus c, we can find the remainder quite easily by using the remainder theorem. The remainder theorem states that if the polynomial p of x is divided by a linear factor x minus c, then the remainder is the value p of c. We now should prove this theorem. When we divide the polynomial p of x by x minus c, we get a quotient q of x and the remainder r. The degree of the remainder r of x must be less than the degree of the divisor. Therefore, if the divisor has degree 1, the remainder has degree 0 and is therefore constant. We now replace x with c in this equation, and we can see that p of c equals the remainder. You should keep in mind two things. The number c is the zero or root of the divisor x minus c, and the remainder is equal to the polynomial evaluated at x equals c. Let's see how it works. First, find the zero, also called the root of the divisor. To find the zero or the root of the divisor, make the divisor equals to 0 and solve the equation for x. The zero or root is 3. Replace x with 3 and perform the calculations. The remainder is 26. Make the divisor equals to 0 and solve the equation for x. The 0 is minus 4, so we replace x with minus 4. The remainder is 250. Find the 0 of the divisor and replace x with 1/2. The remainder is minus 59 divided by 16. We now will see the factor theorem. The factor theorem is a result of the remainder theorem and is based on the same reasoning. The factor theorem states that if p of x is a polynomial of degree n is greater than or equal to 1 and c is any real number, then x minus c is a factor of p of x if and only if p of c equals 0. Let's prove this theorem. If x minus c is a factor of p of x, then the remainder is 0. Let's look again at the division of p of x by x minus c. Replace x with c, then the remainder is 0. In other words, if x minus c is a factor of p of x, then by the remainder theorem, p of c is equal to 0. Should notice that the factor theorem links factors and roots, zeros, of a polynomial, because if p of c equals 0, then c is a 0 of the polynomial p of x. Pay attention in this question. To solve this question, we simply need to use the factor theorem to see if the remainder is 0. Replace x with 2. So by the factor theorem, x minus 2 is a factor of the polynomial p of x. The number 2 is the 0 or root associated with x minus 2, and therefore 2 is also a 0 of the polynomial p of x. We now replace x with minus 1. So by the factor theorem, x plus 1 is not a factor of the polynomial p of x. In practice, the factor theorem is used when factoring polynomials completely. I will show you the process. If a polynomial p of x has a linear factor x minus c, we can write p of x as follows. Then we can use long division or synthetic division to find a polynomial q of x such that p of x equals x minus c times q of x, and q of x has degree 1 less than the degree of p of x. The other factors of the polynomial p of x are also factors of the polynomial q of x. Thus, we may be able to repeat the process on q of x, and so on, as often as possible, to give a complete factorization of p of x. Let's see how it works. If you haven't seen the video on the division of polynomials, review that topic first and then return here. As we already know that x minus 2 is a factor of p of x, we will use the synthetic division to find the quotient q of x. The quotient is a quadratic expression. We can solve that quadratic by using the quadratic formula. Take the roots, factor the quotient, and then we get the complete factorization of the polynomial. The factor theorem tells us that finding the zeros of a polynomial is really the same thing as factoring it into linear factors. But the factor theorem does not tell us how we could find the factors, or at least one factor. I will show you a shortcut to find at least one factor. And from there, you can completely factor out a polynomial. Pay attention in this question. Here is the first tip. If the sum of the polynomial coefficients is 0, then 1 is a root of the polynomial, and therefore x minus 1 is one of the factors of the polynomial. We can see that the sum of the coefficients of p of x is 0. So x minus 1 is one factor of p of x, and we can divide the polynomial by x minus 1. If you sum of the coefficients of this quotient, the result is not 0. But here is the second tip. If the leading coefficient is 1, then look for one root of the polynomial among the factors of the constant term. One root is one of these numbers. By inspection, we can see that minus 3 is a 0 of q of x. So x plus 3 is one factor of q of x. And we repeat the process. Pay attention. You should know to factor a quadratic.